So on this one, we're looking at indices, and we've got lots of different rules involved with indices. So the first one is if you're timesing or dividing two numbers together, you have to have the same base number, which means the same larger number. And if you do, then you can add together the indices if you're timesing, and you can subtract the indices if you're adding. So as an example to those, this first one I'm timesing. So I've got 4 times 2, which is 8. And then I've got a cubed times a to the 4, which is a to the power of 3 plus 4. The second one, I've got 3j to the 5 times j to the 2. So I've got 3 times 1, essentially. It's just that we don't write the 1. So that gives me 3. And then I've got j, and I've got 5 plus 2 because it's times. So again, 3j to the 7. The next one is 6 times 2. And then I've got d cubed times d, which is d to the 4. Don't forget you've got a 1 here, and therefore it's 3 plus 1. The next one is 4 divided by 2, which is 2. And then I've got h to the power of 8 divided by h to the power of 3. So that means that I'm doing 8 minus 3, which is 5. The next one is 18 divided by 3, which is 6. And then I've got k squared divided by k, which means that the 1 here is subtracted from the 2, so it's 2 minus 1, so it's 6k to the 1. It's not written very neatly. The next one is 5 divided by 2. Don't worry if you can't do that, we just leave it as 5 over 2, or you can write 2.5. And then we've got m, and we're doing 10 minus 3.5, and we can just write that as a decimal, 6.5. The next rule is if you're multiplying two different, or multiplying a third by a second third. So if you've got a number to the power of something twice with brackets, so that means that you multiply the two together. So I would have a to the power of 3 times 4, which is a to the power of 12. And then the next one, I need to remember that the squared happens to both things in the bracket. I've got a 3 and an a to the 4, so I've got 3 squared, and I've got an a to the 4 squared. So that then gives me 3 squared is 9, 3 times 3, a to the 4 to the power of 2 gives me a to the power of 4 times 2, which is 8. The next one, again, the 4 goes to everything in the bracket. So I've got 2 to the power of 4, a cubed to the power of 4, and c squared to the power of 4. So that gives me 2 to the power of 4, which is 2 times 2 times 2 times 2, which is 16. You can use your calculator as well. And then I've got a to the power of 3 times 4, c to the power of 2 times 4. And the last one would be done in the same way. The next rule is if I've got a fraction as my indice or as my power. So when I have a fraction, that means that it's the root of that number. So for example, if it was 1/2, it would be square root. If it was 1/3, it would be the third root. If it was 1/4 or 1/4, it would be the fourth root, and so on. So 4 to the half is the square root of 4, which is just 2. 6 to the half is the square root of 6, which we can't do. 3 to the half is the square root of 3. 9 to the half is the square root of 9, which I do know. And 5 to the half is the square root of 5. If I had 27 to the power of 1/3, that's saying the cube root of 27, which is asking for what number times by itself 3 times gives me 27. So what times by itself 3 times gives me 27. And the answer there is going to be 3. That's my cube number. Don't forget you should know all of the cube numbers from 1 to 5. We can also have fractions as powers where we have a numerator and a denominator. So when that's the case, it's exactly what we've just done, but then we have to use the power at the end as well from the numerator. So 8 to the 2/3 is a little bit like me saying 8 to the 1/3 squared. And that would times the two powers together, which would give me 2/3. So that means that I've got the cube root of 8, and then I'm going to square my answer. So the cube root of 8 is 2, and then I'm squaring the answer, so my answer is 4. On this one, I've got the cube root of 27, and then at the end I can square my answer. The cube root of 27 is 3, so I can then square it, and then I find that my answer is 9. This one I'm square rooting. We don't normally write the 2, but you could if you wanted to. The 3, and then we're going to cube the answer. Now we don't actually know the square root of 3, so we have to just leave it as the square root of 3. When we cube it, we just get this. We can't write it any simpler for that question. If you have a negative indice, then the negative just makes it 1 over, or it flips it upside down. So for example, 2 to the power of minus 1, the minus makes it 1 over 2, and then that's to the power of 1, which just keeps it as 1/2. 4 to the minus 1 gives me 1 over 4 to the power of 1, so it's just 1/4. This would be 1/9. The next one is 5 to the power of minus 2, so that means that it's minus, so 1 over 5, but this time the whole thing is squared. 1 squared is still 1, 5 squared is 25, so it's 1 over 25. So I use my negative to flip it upside down, and then I've still got 5 squared. The next one is 1/2 to the minus 1, so I flip it upside down, I get 2 over 1, and then that's all to the power of 1, so it's just 2. We don't have to write the over 1. So a few harder ones to have a think about. We did some of these in the lesson. 36 to the minus 3 over 2. So that's asking me to do 36, but it's 1 over 36 because I'm using my negative, and that's still to the 3 over 2. Now I need to square root everything for the 2 at the bottom. So if I square root everything, then I've got the square root of 1 is still 1. The square root of 36 is 6. And now I've just got the 3 left. Now I can do the 3, which is to cube everything. So 1 cubed is 1, and then 6 cubed. You don't have to know this one off by heart, but 6 cubed is 216. You only need to know 1 to 5. The next one is 16 to the 1/2. So I'm going to use the negative first to flip it upside down. So I've got 1 over 16. But I've still got the power of 1/2. Then I can use my denominator to square root it. So that's going to give me 1 over 4. I've square rooted both numbers. And that's still to the power of 1, but we know that that's just 1/4. Okay, so there's just some questions to have a think about that are a little bit harder